But certain problems, I'll just go through it real quick. You don't have to do it. For example, like number 3. So it turns out that you need to know something called the remainder theorem. Oops. Remainder theorem. All right, so it says that if you figure a function when it's evaluated at x equal to a, some kind of random point, and the value is 0, and that's called a 0 of a function, right? Which is just the x-intercept. So you can conclude that you could extract a binomial factor in such a form, x minus a, the same a that you see over there, from the function f of x. So it could be written as x minus a as a factor times something else, right? That's a g of x. But we're not concerned with the g of x. All we cared is if we can find out such an a, so we can extract that factor, right? And that's why you're trying to get that factor based on the chart, right? They pick the few values of x, right? They tell you that the function of x will be either 30, 12, right? 0 or 2, right? But you see that from the Remainder theorem, you should be looking at the third row, right? So when a function vanishes, and that numbers of x, right, makes it so special, so you can use that to construct a factor like that, right? So now, what do you say? How much do you think that the a has to be for our problem? 3, right? Therefore, it's x minus 3. Right? So problems like this, I guess maybe it's getting less popular because it's pretty much like checking if you know some conclusion that you get it. But it could be also it's module 1, right? And it's the third problem, module 1. You know how module 1 is supposed to be easy enough, right? For you to just quickly get them done. But when you think about that, if it's supposed to be easy, then you cannot afford making the small mistakes, right? Or not knowing certain things, right? Anyway, wait, let me see. Am I recording this? All right, so now this one, and also I'm gonna tell you what I realized when I was trying this problem in the morning. I told you in the past, when you solve an equation for SAT, just do decimals, right? So just type it in, and I didn't realize that our students, or some of them prefer type in both sides into decimals, like the 2 separate equations, right? And see how they intersect, right? And that will be the point of intersection or the solution. But I didn't do that. What I did was I just typed in the whole equation into decimals. So then it shows me nothing on the grid. So then I was thinking, well, is that no solution at all, or is it infinite many solution, right? Then I did the math and I realized it's infinite many solution. So that made me think that what if our students do something like that? Realize it could be no solution since they don't see anything on a graph, right? So they better figure out the math, the right way. But it turns out that if you do 2 separate equations, right? So you type this up, right, as one line, type that up, right? See how they intersect. Then you will see that 2 lines that just, one on top of the other, right? That means they intersect at infinite many points. So that's infinite many solutions, right? But I think that when it comes to technology, things I never get to seriously try the SAT, not to mention in the blue book. So you'll be better at using those little tricks or technologies, right? But what I can do is, if I notice something that might be risky, then I'll let you know. Anyway, now what about this problem? I do want you to actually think about for a brief moment. So if you can figure it out, that would be great. Right. It's a geometry thing, right? Sum of the interior angles of a polygon, right? In this case, a hexagon. I hope that you remember that conclusion. So what was the formula for the sum of the interior angles of a polygon with n sides? N minus 2. Thank you. Right, it's n minus 2 times 180, or in this case, just pi, right? The same thing as 180. So it will be 4. Yeah. So I used to remember, is it n minus 1 or n minus 2? So I just try it with the triangle. Because I know the triangle, the sum of interior angle will be 180, right? Triangle will be 3 sides minus 2, so 1 times 180. So that's how I remember it was minus 2 or minus 1, right? Yeah, that's all, right? But now you see that the pi thing, right? So and I'm sure that right now, you're getting more and more used to the radians kind of stuff. Right? Anyway, and that was the last problem that I picked from module 1. All right, so now let's see module 2. So I'm sure that you guys have learned the complex numbers before, imaginary numbers before, right? But do you guys remember how to write complex numbers into the standard form, the a plus bi, that kind of form? Especially if you have a complicated denominator. Well, not really that complicated, I mean, a weird denominator. So now, in case that you decide to use the scientific calculator for the SAT, and you happen to have Casio, that's what I know. I believe that it's gonna work on in such an instrument. So in Casio, I know that there's an easy way to change into the complex mode, instead of the mode that you're used to. Well, I guess that some of you use the stat mode, right, to get the mean, right, the median and stuff. So in the complex mode, you can literally type in that expression. Make sure that you use that special symbol for I in the calculator, and just hit enter. It will simplify that for you and write it in the standard form, so you can read off what the 8 is. But if you have to do it algebraically, or go find out if that works out for the test instrument. This must be, a functionality there. So if you do it algebraically, all you have to do is to just multiply the numerator and the denominator with the complex conjugate of the denominator. Then what is the complex conjugate of 3 plus 4i? You guys still remember what that is? Again? 3 minus 4i. So yeah, it's the same real part, but the opposite imaginary part. All right, so whatever number in front of I, you flip the sign of it. But you have to multiply the same thing on the top. So then you pretty much just FOILed everything, right? But turns out that in the denominator, you don't need to FOIL it at all. It has a nice pattern, right? It's the sum and difference. So you will go with the pattern, the real part square plus the imaginary part square. That's it. Okay. On the top, you do have to FOIL it. So it would be the first term, right? 2 times 3, 6. Then the outer term, 2 times negative 4i, so will be negative 8i. Then the inner term will be negative 2i. And a 3, right? So multiply, get you negative 6i. So now the last term, be careful with the signs. You have negative 2 times negative 4, so it will be positive 8. But then you have I squared, right? So you guys remember what I squared is? -1. Yes, that's a imaginary number, right? Or we call it imaginary unit. That's what makes all the complex number possible. So you just simplify the numerator, right? You get 6, but this -1 out of the I squared is gonna turn the 8 into -8. 8, 6, right? -8 gets you -2. Then -ai plus -6i, so it'll be -14i, right? Over 25. So now if you really have to write it in a standard form, like a plus bi, so you're gonna split the fractions, right, into -2 over 25, right, minus 14 over 25, right? So now where do you want to put the I? Right next to 14. That means 14 times I. Or you put the I right next to that fraction. They're the same. Right? It's just like some kind of a cosmetic difference. So the real part is, oops, letter A. So now if you do have any better way than that, instead of using calculator, please let us know. All right. So but that's how they taught all of us, back then. But one of my students in the first period said that she has never seen a complex number problem in SAT practice. I don't know if that's the case. I don't remember if I saw one like that. But I didn't try all the full length packet, like from 1 to 10. So maybe there were some questions like that. Anyway, so now moving on to this one. So now why don't you try it? It's something that we learned back in the fall, right? Which you can also play with using the decimals, right? But yes, you're looking for the circumference of the circle, right? What would you need to get the circumference of a circle, right? And how would you get it from that equation of the circle? Anyone figure out the radius of that circle? The radius is, some say 8, right? Is it 8? Is it 8? Did you do it algebraically, or you can tell from decimals? The radius is 8, yeah. So that makes the circumference 16 pi. Right. So now the standard way is to complete the square, right? That's, I guess, how they design the problem, right? To complete the square, you're gonna find a number on the other side that looks like 64, right? Then take the square root, you get the radius to be 8. Then 2 pi r, right? You get 16 pi. But now you have, decimals. So if you like type it in, right, to see that circle, so you can just literally just read off the radius, right? Just go ahead and find the circle. The center is right here, right? Just count how many squares, right? It looks like 8 squares, right? So it'll be 8. Well, yes, you'll see that the center is at -3, right? That's -5. Each square is -1, right? -3. And I see that it's roughly around here, right? That's the edge of the circle, right? So it'll be, it's close enough, right? If you think it's 7.5 or something like that, I guess it will still be good enough for you to figure out what to pick. But what concerns me in the first place is all 2 options are kind of nice in numbers except for letter C, right? So I was wondering if they decide to give you some ugly numbers, then later on that number on the other side is not a perfect square, right? So you get some decimals, right? That makes it a little bit harder for you to read off the radius from decimal. I don't think it will be very likely, but you never know how they do that. Anyway, okay, let's see. Now this one, I don't feel like you guys have to do this algebra to figure out what an x is, but I do want you to either look up or hopefully recall back in geometry what that conclusion or theorem is called when it comes to a exterior angle. Was there a theorem talking about how the exterior angle is related to something? So those two angles add up to be that exterior angle, right? So yes, I guess that's called maybe exterior angle theorem or whatever, right? The exterior angle is equal to the sum of the two non-adjacent angles. The students said, can't you just get the supplementary angle of this guy? Because, you know, if this is 180, the other is 62, right? And, you know, that student is actually a big fan of having the sum of interior angle of a triangle to be 180 and just add them all up, right? To be 180 and figure out what the x is. I mean, yes, that's probably a better way to remember this conclusion. Because you see that why they figured out this angle has to be the sum of the other two, because that theorem came from the fact sum of the interior angles of a triangle is 180. Because you literally subtract this guy from 180 to get the supplementary angle that add up to be, you know, 180 again, right? This is why I think that some of the problems in the packet might be, you know, outdated, since I thought that usually when it comes to geometry problems in SAT, they're less straightforward than that. Because you've seen this part for a second time. If you know the conclusion, then you know how to figure it out, right? Anyway, but again, you never know. If there's a problem like that, then you know you better get it right. Now this one, it might be surprisingly easy, or it might be super confusing for some reason, right? You know, or it's just a average problem. So, but I do want you to try to figure it out, right? But the bottom line is, do not overcomplicate it. Anyone figure this out? Which one? 0.5? How do you figure out it's 0.5?
Because there's two sides to a coin.
But it's an unfair coin. Therefore, you know, if you toss for 20 times, turns out that they're more than half the times it lands, you know, a heads up. Yeah.
14 by 20 to get 7.
Turns out, yeah, that seems to be the way. But I mean, why are we mentioning
But then it's
the odds, right? Or the probability of landing on heads the 21st time. Right? Is that something that matters? 21st time?
yeah, wouldn't it be because you the only information you get is about landing on its heads and it's asking again for its heads.
Uh-huh. Well, I mean, technically speaking, that this is also another piece of information that you could have used for calculating probability. But now, if you decide that 14 times divided by 20, if you get the probabilities of a unfair coin, right, with the heads up, that applies to a individual event, right? So that's probably, so let's say, well, a couple weeks ago, that was probably my first time in US that I actually been to a casino, not for gambling, you know, it's happened to be there, you know. So, and it wasn't So anyway, so that surprised me. How what the casino really looks like. Do you guys know which game or whatever they play out there? They have the best winning odds in a casino. Yes. Yeah, but I don't think that many people realize that. But it doesn't mean you get to win, right? So you go play blackjack. But statistically, you have the best chance to win because you play with people, right? And also the way they design the game, right? And the worst one of the worst one is the machine they just play with the stuff, right? And it's usually for old people. You just sit there, right, for hours to play with the coins, right? And that's why I thought that would be not necessarily young people, like middle-aged people. There's so many old people there. Anyway,
I think Hard Rock, which one was you like?
yeah, hard. Yeah,
The cigarette smell, oh my god.
yeah. That's also another thing that because I've been to the one in Vegas, I didn't get in. I can tell how fancy it is. I don't think it will be like that. Even I didn't get to verify it. Anyway, so now the thing is, let's say a blackjack, the winning odds is 45%. So they do the big data, they realize, the game is designed to be 45%, right? So you win, let's say 4.5 out of 10 times you play, you win, right? For 4.5 times. But if you win, if you go play once, do you think that, what, I'm probably gonna win half the money back? That doesn't work that way, right? You play once, you may lose, right? Play 2 times, 10 times, 100 times, you probably lose every single time, right? So that's the interesting thing of statistics to me. Maybe you also feel the same way, right? So somehow that whatever works out in our own life seems to be always those bad data points. If you want to use the statistics to see that if you could make some better decisions, well, you better respect the data, right? But this is like when you see those people winning the jackpot, right, or Powerball, right? They just go buy a ticket, right? So not every single one keep buying ticket for decades, right? So you might say, well, how come that I don't get to be the one? I can go buy tickets all the time, right? But you cannot use the probability to explain something that happens once, or no, you know what, if you're self-involved, then it gets worse. So yeah, and it turns out that there is a way to calculate if the unfair points lands heads up for 21 times in a row. And let's say it has been heads up for the first 20 times. So now they say, hey, what if the 21st time it's still a heads up? Is there a way to calculate the probability? Turns out there is, and you don't need to know anything more than what they just told us. And what you have to do is take 14 divided by 20, you get 0.7. You're gonna raise that to the power of 21, which is highly unlikely, right? And not just for fun, you guys know how to calculate the probability the sun's gonna rise tomorrow.
That's
5%, right? So how do we know? You never know that maybe tomorrow is the end of the world.
That's
So, here's the way you could calculate it. So you say, since when people realize that the sun's gonna rise and fall every day? So from that day, let's say, I don't know, maybe let's say or you know what, for a baby who's only 100 days old. So maybe he or she realized, oh, the sun rise and fall, every day, right? For the past 11 days. You know what? Now, for that baby, the sun could rise for 101 days in a row, but it may not rise tomorrow. So there is chance that sun might not rise, which will be 1 out of 101. But the sun's gonna rise, right? And the odds for the sun to rise for 100 times, in a row will be 100 over 100, 101, right? So that's why it's highly unlikely the sun's not gonna rise tomorrow, since it's been rising every single day, ever since that we realize it does, right? But isn't that just the same thing of calculating winning odds based on how many times something happens, right? But in this case, they emphasize that it's the 21st time, right? It's not for all that many times, it's a single event. Okay. Yes, it is just 70%. All right. Now for this problem, you know what? Even though it's not a multiple choice, but I'm gonna give you two choices to pick from. I'll make sure that I don't get Proctor. Yes, maybe Dr. O'Neill, see if he's gonna provide you that. All right. So now the options are a equals 30 or a equals 1/30. All right. So you think about that and let me know what you're gonna pick. I said, oh. Ugh. All right, so these two models are pretty much the same, right? It's just that they somehow don't like to put in the month n as the power, right? So like a 1, 2, 3, then for the first, second, and third month, they decided to put in the days. That means, if you want 1 month, right, in the first model, then here you're gonna have to put in 30 days. Yes.
Would A be 1/30?
Okay, so Logan, you pick letter B, right?
Yeah.
So now, if you have an answer, if you feel like picking, picking an answer, raise your hand if you pick letter A. Okay, letter B. All of you, okay. So I guess this is probably why that they choose not to give options, because I think that this looks somehow pretty reasonable if you're thinking about 1 month 30 days, right? But if you realize, okay, could it be 1/30, right? Maybe it's just too easy to say 30, right? Now, how do you explain it, Logan? Why is it
Trying to
1/30?
find 1 month.
Right.
Because let's say you want to find 2 months. If you multiply it by 30 times 30 or like 30 times 60, you get like a crazy number that's an exponent and it just doesn't make sense.
Okay. So
You multiply because the thing is the two exponents are multiplying each other, so it would be like 1/30, but times 60, which gives you 2, and that's how many months there are.
right. So that's exactly, you should be looking at these two models because they are the same model. It's just that the power, right, was written in a different way, but you have to make sure that the power will still match, right? So like he said, what if you want to go with 2 months? N has to be 2, but you put in 30 days. But that power still has to be 2, right? Since it's the same model, and A will have to be 1/30th, to make it work. Okay. And that's the little catch here, right? So yes, it's 1/30. Okay. All right, so now let's see. Oh, here's another good one. All right, so this is 35-degree, and they're asking you how much this angle is. I mean, so just take a guess, right? Is there a conclusion? What is it called? All right, so Karina says that this angle will be exactly double of the small angle over there. Right? So you guys all learned it before?
Yeah.
I like to
Hey, you still remember?
I can't remember. I was like,
Or if you guys can't remember all the way from geometry, then how come you couldn't remember some of the identities?
yes.
But you didn't remember, so at least that makes sense.
But
But I mean, look at these numbers, right? I'm sure that no one's gonna pick 35, right? 55 is still a bit too small, I guess, right? So it's gonna be either 60 and 70. So now I think that it's gonna be 70 because it's double, right? The conclusion better be some kind of an interesting conclusion, right? Or I mean back in those days when we do geometry, when I do geometry, so we're doing it on paper, so I can just literally draw an angle like that, make it so close to the actual size of the angle. I'll go compare it with that bigger angle. See, it's like exactly 2 times as big,
Yeah.
right? We can do all of that. But I'll say that 70 will be the best guess, right? Anyway. Now 19. So let's say if I give you only 20 seconds to figure this out, how would you do it? Already? I got 5 seconds.
There's no solution.
Yeah.
There's no scan.
I don't know how, but I sense that you could do that in that mode or in a way. 5 seconds. All right, time. Which one would you pick? Wait. Anyone pick A? No? Okay. B? C? B? So it's A. So I mean, maybe you realize that the top can be factored in a way, or you realize that you can recognize the denominator, however you do it. But I think that one of the best ways, try to be safe, is not the best way, probably would be something better. But one of the best ways is just set x to 0. You'll see it. If you set x to 0, that kills all the first terms, right? Just again, negative radical 3, negative 3, positive 3. But when x equals 0, you have negative 3 over radical 3, so it has to be negative radical 3, right? So I sense that this is not the kind of problem you should try something more practical, right? Instead of going through some algebra. So there's a wide range of a problem like that. You should all do that. Not to mention module 2, and I've said it for so many times, is the module 2. It is how you could solve problems in a more creative way, right? And still make it right. That makes you stand out. Okay. So you might see that sometimes it's hard to go from 90 percentile to 95, or which is going to be even harder to go from 95 percentile to 99 percentile, because it's probably because that when you're spending too much time on certain problems to get it right, you get less time for some other problems that you could have figured out given more time. So that will place students at certain percentile, right? Now one last problem. All right, so then we'll call it a day. The last problem. You guess?
Yeah.
Oh, they can.
It's not 28.
You gotta tell me.
No. To be honest, I don't know.
Oh, were you there? That's what you did? All right. All right, to find out a B. Now you have two equations, right? When they have infinite many solutions, that means these two equations, if you plot them, right, there are two straight lines, but if they overlap, right? So basically they're the same line, then they have infinite many points of intersection. And the way to quickly do that is to realize that if this guy is a 6, so you can multiply the first equation by -2 to turn into the second equation, at least that the right hand side works out, right? -3 times -2. But now you're ending multiplying -14 with -2. That will match the B. But since B has a negative sign, right? That makes the B negative 28. Right. So also just be careful with the sign, right? But I'm sure that you know, you could do that even in decimals, but it just takes some time to play with those parameters.